Hi, in this video we are going to see how red-black tree works. Complete presentation and Java code for the red-black tree is attached in the description. A binary tree where all the values in the left subtree are less than the parent node and all the values in the right subtree are greater than the parent node is called as binary search tree. If there are n number of data is available, then linear search requires n comparisons. But in contrast, binary search ideal search time complexity is log of n based to the 2. But in the worst case, for an example, ascending order sorted data, a binary search tree will be right skewed tree. In a similar way, because of input data, binary search tree can be left skewed or left heavy or right heavy tree. In such cases, worst case time complexity tends towards big O of n rather than log of n based to the 2. In order to resolve this drawback, various height balancing approaches are suggested, such as AVL tree, B tree, B plus tree, and red-black tree. So in this video, we are going to see how red-black tree works. So, what is a red-black tree? It is a binary search tree where each node holds value, address of the parent node, address of the left subtree and right subtree. Additionally, it holds color value of self, that is either black or red. In the red-black tree, if a node does not have a value associated with it, then it is called as null child. Every red-black tree should satisfy 5 properties. Number 1. Every node is either red or black. Second, root node is always black. Third, null child who are leaf nodes are always black. 4. Parent node of a red node cannot be red itself. Hence, from root to the leaf node path, there cannot be 2 consecutive red nodes. Last and the fifth one, from root node to all the leaf nodes, every path contains equal number of black nodes on it. So, how the red-black tree maintains the self-balancing? The red and the black color is meant for balancing the tree. Newly created node is always a red in color because inserting a new node as a red does not hamper the depth property of the red-black tree. So, based on the properties of the red-black tree and above conditions, after each insertion of the new node in red-black tree, the resultant tree is recolored or rotated only and only if it is hampering the properties of red-black tree. Let's see how to insert a new node in a red-black tree. Every node is inserted as per the binary search tree algorithm only, where left subtree is less than the parent node and the parent node is less than the right subtree. If the red-black tree is empty, then the new node, which becomes a root node, is colored as a black. Else, every newly inserted node is of red color. Before we move on to actual cases of the insert operation, let's first clear the terminologies that we are going to use ahead. If newly created node is n, then the parent of the new node is p and parent of node p is g, which is actually a grandparent of the new node n. Also, the sibling of parent node p is u, that can be referred as uncle of the new node n. Based on the color of uncle node u, there are 2 main cases of insertion in the red-black tree. Case A, where uncle node u is of color red. Here, no rotation but simply recoloring process is applied. Parent node p and uncle node u are recolored as a black. Grandparent node g is recolored as red, but if the grandparent node g is a root node, then it is kept as a black only. For example, in an existing red-black tree, if the new node with the value 61 is inserted, then as per the binary search tree insertion algorithm, 61 along with the null children becomes a right child of 53. New node 61 is red as per the algorithm. Here, since uncle node 13 is red, parent node 53 and uncle node 13 of new node 61 are recolored as black. Grandparent node 33, that is of the new node 61, is a root node. Hence, it cannot be recolored as red. So, node 33 remains black colored. Similarly, insertion of 43 or 18 or 10 instead of 61 will make new node as a red. Attach as per the binary search tree rule. Parent node and uncle node, that is node 13 and node 53, will be recolored as black. While node 33 is a grandparent node but a root of a tree, hence retains a black color. Case B. When uncle node is of black color. Now, if node N is a right child of parent node P and P is a right child of grandparent node G, then the single rotation called as RR rotation is performed. In another case, when the new node N is a left child of parent node P and P is a left child of grandparent node G, then the single rotation called as LL rotation is performed. Both RR and LL rotation means rotating parent node P by grandparent node G. That means parent node P will take place of grandparent node G and G will become right or the left child according to its value. In both of the cases, that is LL and RR rotations, after rotation, parent node P is recolored as black and grandparent node G is recolored as red. Another variation in the case of uncle node U is black are if the node N is right child of parent node P and P is a left child of the grandparent node G, also called as LR rotation. Vice versa, if the new node N is a left child of parent node P and P is a right child of grandparent node G, then it is called as RL rotation. Both LR and RL rotation are double rotation, where first new node N is rotated by parent node P and later on new node N is rotated by grandparent node G. After double rotation, new node N is recolored as black and parent node P is recolored as red. Additionally, after LR rotation, grandparent node G is also recolored as red. Here, in this example, insertion of 48 makes LR rotation case, whereas insertion of 65 after inserting 70 makes RL rotation. In the next video, we are going to see how to delete a node in red-black tree.